Hello everyone. In this video I'm going to show you how you can apply time series analysis using Python. This video is the part 2. In the previous step we talked about the data preparation and data visualization. I show you how we collected data and imported into the Jupyter Notebook, and also we applied some cleaning operation over data. In the next step, we created the line graphs for the US unemployment rate. In this video, I'm going to talk about the step 3, data analysis, and I'm going to run the ARIMA model to the time series data. In the time series data, we should consider that our data should be stationary. Stationary means that the properties of the data, such as means, variance, and covariance, do not change over time. In other words, time should not be as a variable in the time series data. Another point here is that seasonality and trends are not stationary because they demonstrate the values of the time series at the different times, such as the temperature in the winter is always low. So each winter time, we can expect the certain value of the temperature as a seasonality. So this value is a seasonality, not the stationary. For example, in this graph, you can show the stationary. In the top left line graph, the mean is stationary, but in the right graph, the mean is not stationary. So you can see that the time plays as a effective variable here. Or in the other case, the variance is stationary. You can see that the green line graph here is stationary, but the red line graph is not stationary. And also covariance too. Covariance item should be stationary too, and in the case of the non-stationary, we should create the stationary data. To create the stationary data, we can design a hypothesis. The null hypothesis here reflects the non-stationary situation. If our p-value is greater than 5%, our data is not stationary. If our alternative variable and on the other alternative hypothesis reflects the stationary situation. So when our p-value is less than the 5%, our data is stationary. To test these hypotheses, we will apply the ADF test to test hypothesis. There are two types of forecasting: univariate forecasting or multivariate forecasting. In the univariate forecasting, we use the previous data to forecast the future trends. But in the multivariate forecasting, the out of the model variables affect on the model. So we have exogenous variables here, and it is the multivariate forecasting. In the ARIMA, we are going to apply the ARIMA time series forecasting. In this research, ARIMA is a shorten of the autoregressive integrated moving average. There are 3 parameters here. Autoregression, which is the P, it reflects in the autoregression uses the past values as on lag to apply the linear regression model. So when you use it on previous data to apply the prediction, it is a type of the autoregression. And the second component is the integration, which is recognized by the D in the ARIMA model. D obtained through differencing an observation from the previous observation. So in the integration, we're creating a new variable that obtained from the subtracting an observation from the previous step. We applied this operation to reach the stationary data. Next parameter is the moving average. I notified that the ARIMA models is a type of the linear regression models. In the regression model, we have a residual error. So in every prediction, we need to consider the error. So in the moving average, the model uses the dependency between an observation and a residual error from a moving average model, which obtained from the autoregression. Also, there are several types of the ARIMA model: a non-seasonal model, seasonal with exogenous variables, and parameter auto ARIMA, which is a optimized parameter. So I'm going to talk about these types of the ARIMA in the Python. Also, I use these sources for the coding in Python. You can use them as more information to providing the code in the Python. So if you need more information, you can use these sources to reach the original codes. I'm going to use a Jupyter Notebook to apply ARIMA model time series forecasting. First of all, we need to import some libraries in Jupyter Notebook. I'm going to define the column's name as labels. In the next step, I'm going to import the data from the GitHub, and I will put this address under this video. You can download the data as a CSV format, and I'm going to run it. Now I have a data. In the next step, I'm going to adjust the data format. In the first case, I'm going to convert date column to the date time format, and also I'm going to convert the US, Oregon, and Nevada columns to the float format. And then at the end, I'm going to show the data types. Run it. Okay, I need to first define the df as a data and then run it. Okay, now I converted the date to the date time format, which is essential in the time series data, and also other columns to the float format. In the next step, I'm going to show you how you can customize the date. I customize the date through this model. Our data started from the 1976 to the 2020 September 1st, and also I'm going to define the start data from the 1976 to the end date as a September 1st. So, and then run it. Now my data started from the 1976 to the 2020. I'm going to show you how the tail. Okay, data started from the 1976 to the 2020 September 1st. In the next step, I'm going to show you how you can index the date column as an index. I define the data frame 1 and then df point set as an index. I define the date column as an index. So I'm going to show you the df. Okay, now if you can see that the date column changed to the as an index. So creating the date as an index is very important in the time series data analysis. Okay, in the next step, I'm going to show you how you can test the stationary. Okay, first of all, you need to import the diffuser from the stat model library. So I'm going to show you how you can test the Nevada unemployment rate for the stationary. Test the Nevada data to be stationary. So our p-value is the p-value for the Nevada is 0.21. It is greater than the 5%. So our data for the Nevada is not stationary. In the next step, I'm going to test the US unemployment rate data. to be stationary or not. So our data for the US is stationary. So we can apply ARIMA models to this data. But before that, I'm going to show you how you can apply the differencing to the Nevada data to shift to the stationary. I'm going to use the shift function to show you how you can create the first order differencing for the Nevada data. And so I'm going to test the Nevada first order data. Okay, our data here is stationary. So when we moved 6 cells down and then compared with the previous observation, we created the stationary data. In the next step, I'm going to show you the autocorrelation function. To this end, you need to import the plot ACF from the stat models library. So I'm going to use this code to create the ACF plots, autocorrelation plots. Okay. The first row graph indicates that our data is not stationary. We can see that it's started from the high rate to the down, and so this data is not stationary. But in the first order, we moved 6 steps down and then created the difference. The beginning set of the data is not stationary, but in the continuous, they become stationary. In the second step of the creating differencing, we moved 12 cells because our data is a yearly, is an annual, 12 numbers we have for each year. So our data is a seasonality. So we moved 12 cells down and created the stationary data. So our second differencing order is stationary, except the 1 or 1 and third cases at the beginning, but our data is stationary. So when we use the second order differencing, it is stationary. So we are going to save the Nevada second order stationary as a new column. We created the first order stationary here, and then second order stationary here. Also, we can apply the ACF test to check the second order data is stationary or not. In the next step, I'm going to show you how you can create the ARIMA forecasting models. You need to import these features from the stats models library, and also you need to import the PMD ARIMA and stat models API. Also, we need to import the autocorrelation plot from the pandas plotting, and finally we need the mean square error from the scikit-learn metrics and run it. I'm going to show you how you can plot the data. This is our non-stationary data. I said that our unemployment rate data for the US is stationary. So I'm going to run the non-seasonal ARIMA model for the US unemployment rate with the order 111, and then I label this model as a 111 and then run it. Okay, now we can see the summary of our ARIMA statistics. So critical point here is AIC value, which 76 points. So this value is important because we can compare the models with each other based on the AIC. It reflects the accuracy of the model. In the next step, I'm going to plot the residual errors, which is important in the ARIMA forecasting. Okay, this is the left side is our residual, and then also we can see the density around the 0. So it reflects our data, how does fit. Also, we can change the form of this graph by changing the subplot order from the vertical to the horizontal. Okay, this shows our residual errors data, and it reflects the density of our data. Also, I'm going to plot the actual observation with the fitted observation for our basic ARIMA model. So this plot shows the forecast and US unemployment rate as the observation. In the next step, I'm going to create the train data by this code. I'm building a new model. I'm going to use the order 3 as a key, 2 for D and 1 for Q. And I named this model as a 3 to 1 for our train data. So our AIC is minus 316. In the next step, I'm going to use the forecast in the next step, I'm going to use the test section of the data for the forecast. And finally, we are going to plot those forecasting by using this code. So this is our previous data, and we use the 80% of the data as a train and then 20% for the testing model, and then this displays the forecasting based on our test and train. In the next step, I'm going to change only the order of the parameter. I call this model as a 201 and run it. We can show the confidence as a shade for the forecast and linear model. In the next step, I'm going to create the autoregressive model for our US unemployment data. Okay, I'm using this code to create the auto ARIMA forecasting model. Using can help us to optimize the model. It's applied the several models to test the AIC, and then finally the best model is the 010 order. When we use this model, it is the lowest rate of the AIC we can find in this model. So if we use the 010 for our previous 201, we can change the name of this model to the 010, 0, 1, 0, and then run it. In the next step, I'm going to show you how you can plot the diagnostic for our model auto. So this is the graphs for our auto ARIMA. This is the standardized residual and normal QQ. This is the stationary. US unemployment rate is the stationary, and also is the histogram plus the estimated density for the KDE. In the next step, I'm going to show you how you can compare the usual differencing data with the seasonal differencing data for the Nevada. But pay attention to the point that we need to apply the differencing for the Nevada data. However, I'm going to display the original series too. Okay, by applying this, okay, this dark blue is the differencing for the non-seasonal data, and the Nevada data is the non-seasonal too. But this one is the seasonal, and the green line is the seasonal differencing data. The blue line is the non-seasonal, but the green line is the seasonal differencing graph. In the next step, I'm going to apply the seasonal fit stepwise auto ARIMA by using this code. It will take a time. Okay, so our optimized model is the order of 102. So 102 has the lowest AIC based on this optimized evaluation. And this is the statistics for the seasonal ARIMA with exogenous. In the next step, I'm going to show you how you can plot those data for the forecast. We use the seasonal ARIMA model to predict the future trends. So this is the predict for the unemployment rate for upcoming years based on the ARIMA model. Thank you for watching this video.